Okay, folks, what I'm going to do is just give a very, very quick rundown of what we went through for notes today for the polynomial expressions lesson 1 section. So I first did a quick review of how we expanded polynomials, because the whole idea of this new unit is to go from expanding polynomials to factoring polynomials. So taking our polynomial looks like this and turning it back into this, or a polynomial that looks like this and turning it back into this. Today's lesson focuses in on monomials times polynomials, or really monomials times binomials. I did a quick review on how to find the greatest common factor using prime factorization, because that could be key for some people. Talked more about what the difference between expanding a polynomial is. So taking this 2x times x plus 5 and expanding it to 2x squared plus 10x by multiplying 2x by x and 2x by 5, which is the opposite operation to factoring a polynomial. Well, if I had 2x squared plus 10x, then I know I should be able to factor it into 2x times x plus 5, because that's exactly where it came from here. I didn't dwell on that too long because I really wanted to get into the examples. We looked at finding the greatest common factor between 48 and 72, of which I already did the prime factorization tree above. So I did that prime factorization, showing that the greatest common factor between 48 and 72 is 24, because these values are common. This 2 and this 2, this 2 and this 2, this 2 and this 2, and this 3. So 2 times 2 times 2 times 3 is 24. We can also do the same process, prime factorization, with a term that contains variables. So for example, 6a cubed, I'll use my highlighter here. So for example, 6a cubed here, prime factorizes into 2 times 3 times a times a times a. 9a squared b factors into 3 times 3 times a times a times b. And then our greatest common factor are the parts that are the same, which is 3a times 3a squared. And then the next step is really taking that greatest common factor and dividing it into our term right here to get us 3b. Taking that greatest common factor and dividing it into our term, 6a cubed divided by 3a squared gives us 2a. Then we looked at a couple of examples looking at the greatest common factor. Hopefully you can start to see these by inspection. So you're just looking at them and seeing them. Seeing that 8 and 20 have a greatest common factor of 4. And then x squared and y squared have a greatest common factor here over x cubed and x and y cubed of x and y squared. So you always take the lowest exponent of each of the variable terms as long as the variable is common to both terms. So x is common, whoops, wrong color. X is common between both terms. The lowest exponent is a 1. Y is common between both terms. The lowest exponent is a 2. So that's how we get our greatest common factor of 4xy squared. And then if we divide each of those terms by our greatest common factor, we get 2x and 5. That's really the next step. Okay. Give me a little bit of chance to look at that. Pause the video, take some notes if you wish. This was just talking about how to find that greatest common factor using prime factorization. I guess I probably should have talked about that first, but oh well, now you can see it. Once you prime factorize both of these terms, 8x squared y squared is 2 times 2 times 2 times x times y, and 20xy cubed is 2 times 2 times 5 times x times y times y times y. You can see that the 2, oops, wrong color again, that the 2 here is common with this 2 is common with this 2, this x, this y, this y, this y, this y. Hence, you can see how we get our greatest common factor of 4xy squared. And then we did some examples. So looking at these examples, I'll give you a bit of time, pause the video. see if you can determine the greatest common factors. Again, unfortunately, I don't have the time to go through all of these examples. So you can write those down and try and determine them on your own. Just as a quick one, let's look at B. Greatest common factor between 18x to the fourth y squared and negative 24x cubed y to the fifth. Both 18 and 24 divide by 6. X is common in both x to the power of our lowest exponent 3, and y is common in both y and lowest exponent is 2. That line green is an ugly color to be using. I'll switch that. Then we went on to some more examples, just basically doing the whole process in together. So I skipped 3 and 4 because I didn't like the way they're presented. So we just went straight into 5 and looked at these examples. So I'll blow it up a little bit. There's A, pause the video, take some notes. There's B, pause the video, take some notes. There's C, again, pause the video, take some notes. Here's D. And here's E. Okay. So I'll do I'll do C just as a quick example. I'm going to erase it and then I'll do it so you can follow along. So looking at all of these terms, I look at the greatest common factor between 10, 8, and 2, and I see that they all divide by 2. I look at my exponents that are common between each of the terms. I see that A is common between all terms. What's the lowest exponent? Well, the lowest exponent is 1. I look at B. B is common between all terms. I look at the lowest exponent, B squared. Then I take each of these terms and I divide or factor out that greatest common factor, 2ab squared, 2ab squared, 2ab squared. So 2ab squared is my greatest common factor. Well, what am I left with when I take this first term and I divide it or I factor out 2ab squared? Well, 10 by 2 is 5. A cubed by a is a squared. B squared by b squared is just 1. They cancel out. I do my next term, 8ab cubed. 8 by 2 is 4. A by a is canceled, it's a 1. B cubed by b is just b, using our exponent laws that we learned in a different unit. And our last one, 2ab to the fourth divided by 2ab squared. 2 by 2 is 1. A by a is nothing, it's just 1. B to the fourth divided by b squared is b squared. And there you have our factored form of that polynomial. So greatest common factor work is always the first step that we do in all of our factoring questions. Then we do other stuff, okay, which we'll find out tomorrow. Here we looked at a word problem, basically just looking at the difference between using a factored form of an equation or the equation itself. It's not super important that to kind of know the example. Just know that we're able to take this equation, area equals pi r squared plus pi r s, and factor out a greatest common factor of pi r. Pi is common to both, and r is also common to both, and the lowest exponent is a 1. So I should be able to factor out pi r for each term. I factor out a pi and an r from pi r squared, I get r. I factor out a pi and an r out of pi rs, I get s. And there's our simplified factored form of that equation. Pause the video if you need to take some notes here. And then I assign some questions. So number 1, number 2, number 3 odds, number 6 odds, number 7 odds, number 8, all of them, and then 10 and 13 as kind of harder, tougher questions to try. Okay. So in a perfect world, I get this posted to YouTube tonight. You have it to refer to and take some notes. And then hopefully I will be able to post something tomorrow at some point for the next lesson that we're doing. Just know that I think the next lesson, we're not going to necessarily be following the workbook at this point. I'm going to do some worksheets with some other notes. So it'll be on separate paper. I'll show the questions. You'll just have to work on them on separate paper. If you have any questions, please send me an email. You have my email address. Send me an email. I'll try and get something back to you. Otherwise, we'll see you. Catch you next time.